Hello everyone, I'm Debbie and today I want to show you how we truly master machine learning by breaking down the process into 9 steps of SML wheel framework. This is into Hi guys. Hello everyone, I'm Debbie and today I want to show you how we truly master machine learning by breaking down the process into 9 simple steps and we call them the SML wheels framework. This isn't theoretical. It's systematic structure for building models that are economically rational. My project tackled credit card fraud detection, a problem immediately defined by a challenge of extreme class imbalance. This fact drives me to the first wheel, which is problem formulation. My goal was not accuracy, but saving capital. We defined the error with the highest costs, a false negative, that is missing a fraudulent case when it's uh, misclassifying a fraudulent case as legitimate when it's actually a fraudulent case. This focus on asymmetric cost became our driving force. Hello everyone, I'm Debbie and today I want to show you how to truly master machine learning by breaking down the process into 9 steps or 9 steps of SML wheel framework. This is not theoretical, it's a systematic structure for building models that are economically rational. My project tackled credit card fraud detection. This problem is immediately defined by a challenge of class imbalance. This fact drives me to the first wheel, which is problem formulation. My goal was not accuracy, but saving capital. We defined the error with the highest costs, which is a false negative, missing a fraudulent case as the enemy for our model. This focus on asymmetric cost became our driving force. In wheel 2, where we have data exploration, after confirming the class imbalance, we prepared data rigorously. We used stratified sampling to ensure our training data was representable, and we enforced strict leakage prevention by using only the training set statistics for standardization. For wheel 3, which is the function space, I selected 3 diverse models: the logistic regression, support vector machine, and random forest to compete for the best solution. The most critical step was wheel 4, the learning principle. To enforce our economic goal, we used cost-sensitive learning. I calculated the class weights and applied it to every fraud case. This forces the model to minimize the weighted binary cross entropy. Our technical rigor continued with wheel 5, where we had optimization. We used repeated cross-validation, This robust technique ensures that the performance estimates are stable, giving us confidence in our choice. Under regularization, which is Will 6, I used ridge penalty, where I put sigma, lambda as equal to 0 for the linear model. This wasn't arbitrary. It was essential to stabilize the coefficients and provide robustness against the massive financial outliers found in transaction data. The competition concluded with Will 7, where we have extrinsic predictive comparison. We judge the models on unseen datasets, maximizing the recall sensitivity, and the random forest achieved the highest recall, forming the fraud pattern, confirming that the fraud pattern was not linear. It is, and it's the random forest became our optimal function. I also looked inside the winning model using feature importance in Will 8, which showed that the transaction amount and V4 were the clearest signal of fraudulent activities. And in the final will, I proposed a canary deployment strategy and emphasized the need for continuous monitoring and manage non-stationarity, the fact that fraud criminals constantly change their tactics. Beyond these wills, I also worked on data that had what we call the curse of dimensionality, high dimension, data focused on danger, or this data focused on the danger of multicollinearity, where features correlated and destabilized the model. By examining the correlation matrix, I confirmed this interdependence. Now, my takeaway from all this work is clear. The SML framework taught me that structural rigor and problem formulation are the are far more critical than simply running